So finding the derivative, they want us to find the derivative of y. So what's dy dx? Well, this is going to be the product rule because we have a product. This times this. So the way to find the derivative of a product is to take the first thing and multiply it by the derivative of the second thing. So what's the derivative of this? Of 2 to the x? ln 2 times 2 to the x plus, this is the product rule again, so the derivative, this times the derivative of that plus the opposite,
the derivative
2x, which is the second thing, times the derivative of the first thing. And the derivative of x to the 1/2 power is 1/2 x to the negative 1/2 power.
Yeah.
And then just simplify it. So this thing is going to equal 2x root x ln x plus 2 to the x over, I'm simplifying this, that's 2 goes on the bottom, and this whole thing flips to the bottom and becomes a positive square root. Right, because that's what a negative...
The
negative flips to the bottom. Yeah. Okay, but now your teacher might want you to simplify this. So let's see what we could do to simplify this. You might want this thing to come to the top. So that would become 2 to the x root x all over 2x, because I multiplied by a root x over root x. They're simplifying. Your teacher want you to do that?
I think we can usually just leave it as that.
Leave it like that?
Yeah.
Okay. You could also simplify it a little bit more.
Honestly, like, I think I've kept them as that.
Yeah.
Those are fine,
fine.
too. The first
fine. Whatever your
I don't think
teacher...
he wants us to simplify them, like...
You want to check the back of the book and see it? Do they have answers there?
Yeah.
All right, let's take the derivative of 3x over the cube root of x. There's a couple ways you can do it. You can do the quotient rule, which is somewhat complicated. Or you could, since these both are just x's, you could simplify that, rewrite it as a single power of x. So I'm going to rewrite this as 3 times x to the negative 1/3. Because that's, remember, a cube root is like x to the 1/3, but that's on the bottom. So if I want it on the top, I make it a negative power to bring it up to the top.
Okay.
Okay? And what's the rule when I have x to the a times x to the b? What do I do with a and b?
You
Add them.
I add them together. That's right. It's x to the a plus b. Remember that? Because I have this many x's here and this many there, and so I add them up, and that's how many total I have. So what's the exponent of this x right here, this first x? It's 1. So what can I do with 1 and negative 1/3? I add them together.
Okay.
So what does that equal? 3x to the 2/3.
Okay.
Okay. Does it seem easier to do this or this with the quotient rule? Clearly this is easier, right? So if you see something with the same base, you don't necessarily have to jump right in with the quotient rule, because it looks like that's what you would use. Simplify it, and then you don't even have to use the quotient rule. So the derivative, dy over dx, or the derivative, is equal to, take that and multiply it down.
Okay.
So it's 2/3 times 3x to the, now subtract 1 to the 1/3.
Okay.
And now that simplifies how?
Just multiply 3 over 1.
3's cancel?
Yeah, it's just going to be 2.
That'd be negative 1.
Yes, thank you. It's the negative 1/3. Thanks, good point. 2x to the negative 1/3, which, if you want to simplify that, is just 2 over the cube root of x.
Okay.
And then you could if you wanted to do more. Sometimes they want more, sometimes they don't. I think probably this answer is sufficient for most people.
Okay.